2025 was the year AI crossed the line. Robots outperformed humans. New models rewrote the rules. China, OpenAI, Google, Apple, all accelerated at once. In just 1 year, AI moved from experiments to real-world power. This video is a curated recap of the biggest AI breakthroughs of 2025, taken from the best moments on this channel: models, robots, and technologies that changed everything. If you want to understand where AI is heading next, this is the story you need to see. Now let's start with how China's AI robot outperformed humans. So, a robot in China just sat down and did embroidery. Like actual hand embroidery with a needle and thread. And I know what you're thinking. So what? Robots can do loads of things. But here's the thing. This is genuinely one of the hardest tasks any humanoid has ever pulled off. And it changes the game in ways most people haven't realized yet. This happened on December 22nd at a live demo by TAR Robotics. Their humanoid got on stage, threaded a needle, used both hands, and stitched a logo in real time in front of an audience. No edits, no tricks, just a robot doing something that's honestly been considered nearly impossible for machines. And if you've ever tried to thread a needle yourself, especially when you're in a hurry or the light's bad, you know exactly how fiddly this is. Now imagine asking a robot to do it. The problem is that embroidery breaks all the rules that robots are good at. Industrial robots love predictable, rigid tasks. Pick up a metal part, place it exactly there, repeat 1,000 times without variation. They're brilliant at that. But the moment you introduce soft materials, everything falls apart. Thread stretches and twists unpredictably. Fabric moves and deforms under pressure. You need constant tiny adjustments to force and position across a long sequence of steps. One mistake and the thread snaps or the stitch misses completely. It's a nightmare for automation, which is why skilled human hands have dominated this kind of work for decades. So when this robot pulled it off smoothly, staying stable the whole time with both hands working together, adjusting force in real time, tracking the needle visually without hesitation, people in robotics immediately understood what it meant. Because if a robot can handle embroidery, it's suddenly not just about stitching logos. You're now talking about wire harness assembly, precision electronics work, fine mechanical assembly. All those delicate manufacturing jobs that still need human workers because machines just couldn't cope. Until now. The CEO of TAR Robotics explained how they managed it, and it lines up with something we're seeing more and more in AI. They call it a data AI physics trinity. Basically, instead of treating data collection, model training, and physical robots as separate things, they've connected everything into one continuous feedback loop. Real-world data gets fed into their embodied AI model, which learns general physical skills like balance, coordination, force control, and vision under uncertainty. Skills that actually transfer from one task to another. Then those skills run directly on their humanoid platforms. And here's the kicker. The gap between what the AI learns in training and what it can do in the real world is tiny. That's why the robot held together on stage under real conditions instead of falling apart like so many live demos tend to do. Now let's take a look at the craziest robots just released. This past week has been absolutely insane for robotics. Engine AI just dropped their combat-ready T800 humanoid that can literally perform martial arts. Galbot raised $300 million, and their G1 robot is already running stores across China. CATL and Spirit AI deployed the world's first large-scale humanoid workforce in battery production. Primesh AI introduced the Hytron, a robot that cleans toilets better than any human ever could. And Oversonic Robotics out of Italy announced a major partnership for their Robi humanoid. This is the future, happening right now. Let's dive in, starting with the most jaw-dropping reveal of the week. Engine AI, a company out of Shenzhen, just unveiled the T800, and yes, they named it after the Terminator. This isn't your typical industrial robot that just moves boxes. The T800 stands 5'8", weighs 165 pounds, and has been designed with something they're calling combat-ready architecture. The demo video that dropped this week shows this thing doing spinning kicks, boxing moves, and dynamic jumps that would make most humans look uncoordinated. It's got 29 degrees of freedom in its body, plus 7 in each hand, giving it 43 points of articulation total. But here's what makes it actually practical. It's powered by an NVIDIA AGX Orin processor delivering 275 trillion operations per second. The max joint torque hits 450 Newton meters. It can move at 3 meters per second. And it's got a modular solid-state battery that gives it 2 to 4 hours of runtime. They've equipped it with 360-degree LiDAR and Intel RealSense depth cameras, so it can navigate autonomously. The frame is made from aviation-grade magnesium aluminum alloy. And they even built in an active leg cooling system, because these joints generate serious heat when they're moving this dynamically. Now, the martial arts stuff is impressive for demos, but Engine AI is positioning this for real work. Manufacturing floors, warehouses, logistics operations, even entertainment venues. They're taking pre-orders now with delivery scheduled for June 2026. The base model starts around $25,000. The maxed-out version with all the premium sensors and computing power hits $50,000. That's actually competitive with a year's salary for a human worker. Except this thing can work multiple shifts without breaks. Now let's talk about what might be the most significant business story of the week. Galbot, which is Beijing Galaxy General Robot Company, just closed a $300 million funding round. This brings their valuation to $3 billion. But here's why that matters. They're not just building robots for demos. The Galbot G1 is already operational in over 30 cities across China. We're talking real deployments, not pilot programs. The G1 stands 5'8", weighs 187 pounds, and has a 190 centimeter arm span. It can reach up to 240 centimeters high and carry 5 kilograms per arm. What makes it special is the dexterity. Now let's talk about how Meta's VL-JEPA changed AI. There's a new AI model out of Meta that might just change how we think about artificial intelligence, called VL-JEPA, and honestly, it's one of those rare moments where you see something and think, yeah, this could be what comes next. Not an incremental improvement, a genuine shift in how these systems actually work. So what makes it different? Well, here's the thing. Every major AI model you've probably heard about, whether it's GPT, Claude, Gemini, they all do the same basic thing. They predict words, show them an image, ask a question, and they'll generate text one word at a time until they've given you an answer. That's how they're trained. That's how they think, and that's what they optimize for. But this new system called VL-JEPA, which stands for Vision Language Joint Embedding Predictive Architecture, throws that entire playbook out the window. It doesn't predict words at all. It predicts meaning directly. And once you understand why that matters, it becomes pretty clear that we've been doing this the hard way for a while now. Let me explain what I mean. Imagine you show a model a picture of someone flipping a light switch and ask what happens next. A human would say the light turns off, or maybe the room goes dark, or perhaps the lamp stops working. All of those answers are correct. They mean the same thing. But to a language model, those are 3 completely different answers. Different words, different tokens, totally separate sequences that share almost no overlap. So during training, the model has to waste enormous amounts of effort learning all the different ways humans might phrase the exact same idea. It's memorizing style and phrasing when all it really needs to understand is the concept itself. That's problem number 1. Problem number 2 is speed. When you're generating text token by token, you can't actually know what the model is trying to say until it finishes the entire sentence. If you're building something like smart glasses, or a robot that needs to react to the world in real time, that delay becomes a serious bottleneck. You're sitting there waiting for the model to finish writing before you can even parse what it means. VL-JEPA solves both of these problems by skipping the text generation step entirely during most of its operation. Instead of predicting the next word, it predicts what the answer should mean, represented as a continuous vector in what's called an embedding space. Think of it like this. In traditional models, the answers, "the light turns off," and "the room goes dark," are miles apart because they're different sequences of symbols. But in embedding space, those 2 answers can sit right next to each other because they mean the same thing. That's the entire game. By working in meaning space instead of word space, you collapse a messy multi-option problem into something clean and learnable. Here's how it actually works under the hood. There are 4 main pieces. First, a vision encoder takes your image or video and turns it into visual embeddings. Then there's the predictor, which is the brain of the system. It looks at those visual embeddings, reads your query, and predicts what the answer embedding should be. Now let's break down why GLM 4.7 is a game changer. China just dropped GLM 4.7, and this thing is absolutely crushing benchmarks that used to be the playground of closed proprietary systems. We're talking serious numbers here, the kind that make OpenAI and Anthropic take notice. And here's the kicker, it's completely open source. So let's break down why this matters. Because GLM 4.7 isn't just another model release. This is a coding-first, agent-friendly system designed for the messy, complicated workflows where most AI models completely fall apart. You know what I'm talking about, right? You start a coding task, the model seems brilliant for the first few exchanges. Then 20 steps in, it forgets what it was doing, starts contradicting itself, and suddenly your entire workflow is chaos. GLM 4.7 is built specifically to avoid that nightmare. The numbers speak for themselves. On SWAB-ENCH verified, this model hits 73.8%. For context, that's a benchmark where the AI has to read a real GitHub issue, understand an entire codebase it's never seen before, locate the exact files that need changing, and produce working code that actually passes tests. When an open-source model performs at this level, that's genuinely groundbreaking. Then you've got Live Code Bench, where it scores 84.9%. This benchmark is closer to actual real-world coding, handling edge cases, constraints, and the kind of messy logic you deal with every single day. But here's where it gets really interesting. Terminal workflows. You know, the stuff where you're chaining commands, managing state, and one wrong move breaks everything. GLM 4.7 reaches 41% on Terminal Bench, which is a massive jump from the previous version. Terminal tasks are basically a stress test for AI agents because the model has to constantly decide what to do next, run commands, interpret results, and adapt. Most models crack under this pressure. GLM 4.7 holds together. Now, the secret sauce here is how this model thinks. It's got 3 thinking modes, and this is genuinely clever design. First, there's interleave thinking, where the model reasons before every single action or tool call. Then preserve thinking, which is the game changer, because the reasoning actually persists across multiple turns instead of resetting every time. And finally, turn-level thinking control, so you can dial the complexity up or down depending on the task. That preserve thinking mode is huge because it means the model doesn't lose the thread during long sessions. It remembers its reasoning, stays coherent, and doesn't drift into nonsense territory. The tool use capabilities are also legitimately impressive. On BrowseComp, which tests web browsing tasks, it jumps to 67.5% when context management is enabled. And on Tau Squared Bench, which focuses on interactive tool orchestration, it hits 87.4%. These aren't just academic numbers. This directly translates to better performance in real agent workflows. Now let's catch up on the biggest AI news of December 2025. We've got Anthropic dropping something called Bloom that's completely changing how we test AI behavior. Google releasing T5 Gemma 2 that actually reads before it responds. NVIDIA pushing out Nemotron 3 for serious multi-agent work. And Mistral finally cracking the code on making messy documents useful. Let's dive in. So Anthropic just open-sourced Bloom, and this is genuinely fascinating. It's not about testing how smart a model is or how fast it answers questions. It's about understanding how AI actually behaves when you put it through longer, more realistic situations. And this matters way more than you might think. Here's the thing. Models are getting really good at looking polished in short demos. They're polite, they follow instructions perfectly. They sound great in those clean little test scenarios. But the weird stuff only shows up when tasks stretch out over time. Maybe the AI starts agreeing with everything a bit too much. Maybe it quietly protects itself instead of being honest. Maybe it drifts away from what you actually wanted, and you only notice after dozens of turns. Until now, catching that kind of behavior was incredibly manual. Researchers had to dream up scenarios, write prompts, run endless conversations, read through massive transcripts, then argue about how to score everything. And as models evolved, those tests got outdated fast. Bloom automates the whole thing. You give it one behavior definition, and it generates entire test suites automatically. Different scenarios every time, but measuring the same underlying behavior. So the model faces situations it's never seen before. But researchers can still compare results consistently. It uses multiple AI agents working together. One studies what the behavior actually looks like in practice. Another creates realistic scenarios where it might appear. Another runs those tests. Then judge agents score what happened. Anthropic tested this across 16 frontier models, with 100 scenarios each. And it even caught intentionally broken models almost every time. The automated judges matched human judgment really well, especially on the cases that actually matter. This is where AI safety stops being theoretical and starts being practical. Now Google's T5 Gemma 2 is taking a completely different approach. Most models today are optimized to respond instantly. They're brilliant at producing quick answers, but they struggle when you give them a ton of material and expect them to actually understand it all. Long documents, mixed inputs, reports with charts and images, places where missing one detail breaks everything. T5. Gemma 2 fixes this with a simple idea. Let the model fully process everything first, then generate output based on that understanding. That's why they went with an encoder-decoder architecture. The encoder takes everything in and builds a complete picture. Then the decoder works from that picture instead of juggling input and generation simultaneously. This is huge for real-world applications. Internal search tools, document analysis, legal files, technical specs. Anywhere skipping a paragraph isn't just a minor error, but actually breaks the entire task. Google released 3 sizes, from 270 million parameters up to 4 billion. And they're designed to handle text and images together across over 140 languages. Now let's see how OpenAI is redefining the future of coding. OpenAI just quietly dropped what might be their most important coding model yet, and it all started with a single word showing up on GitHub: Caribou. Now, at first glance, you might think this is just another incremental update, right? Another model in the endless stream of AI releases we've been seeing lately. But here's the thing. This isn't just another model. This is GPT-5.2 Codex, and the way OpenAI rolled this out tells us a lot about where they think the real battle is happening right now. So let's rewind a bit. GPT 5.2 launched recently, and OpenAI made it very clear this was designed for professional knowledge work. Not hobbyists, not students, but people doing serious, complex work. And that positioning was intentional, because the next logical step was always going to be a coding model that could handle real-world developer workflows. Enter Caribou. Developers started noticing references to this internal codename popping up in OpenAI's GitHub repositories. Now, internal codenames show up all the time. Most of them never see the light of day. But when Caribou started appearing in the actual model selector interface, that's when people knew this was real. That's typically the last thing OpenAI touches before something goes live. Here's where it gets interesting though. Usually OpenAI releases a standard version and then a max tier, right? The max tier is more expensive, more powerful, limited access. But with Caribou, there's no max variant. It's just one model built on GPT 5.2. And that's it. No tiers, no fragmentation. Everything in one package. That's not an accident. OpenAI's been feeling the heat lately. Google and Anthropic have been closing the gap fast, and in some areas they're actually ahead. Word is that Gemini 3 caught Sam Altman's attention internally, and the timing of GPT 5.2 landing basically confirms that. So instead of splitting performance across different price points, they're consolidating everything into one really strong baseline and pushing it out everywhere. On December 19th, Caribou officially became GPT 5.2 Codex and went live for ChatGPT Plus users and API customers. Now, this model is specifically tuned for what they're calling agentic coding. That's not autocomplete. That's not writing a function for you. Now let's uncover why GPT 5.2 dominates coding tasks. So OpenAI just dropped GPT 5.2, and honestly, the drama behind this release is almost more interesting than the model itself. Let me tell you what's really going on here. Just a few weeks ago, something happened at OpenAI headquarters that they probably didn't want you to know about. Sam Altman, the CEO, sent out what insiders are calling a code red memo. And when I say code red, I mean the kind of panic you see in movies when the alarm bells start ringing and everyone drops what they're doing. But this wasn't about a security breach or a system failure. This was about Google. You see, Google released Gemini 3 last month, and it absolutely crushed the competition in ways that caught OpenAI completely off guard. We're talking about an AI that can generate photorealistic images with perfect text rendering, The kind of stuff that went viral all over social media. People were calling it nano banana, and it was everywhere. Meanwhile, OpenAI was sitting there with ChatGPT, watching their users start to wonder if maybe, just maybe, they were falling behind. The Code Red memo reportedly told staff to drop everything and focus on making ChatGPT better. We're talking about delaying features, reallocating resources, and basically admitting that they were losing ground. Some employees even pushed back, saying GPT 5.2 wasn't ready yet and needed more time. But OpenAI had no choice. They had to respond, and they had to respond fast. And here's where it gets really interesting. Because this isn't just about two tech companies fighting over who has the better chatbot. This is about billions of dollars, entire ecosystems, and the future of how we work. Anthropic just released Claude Opus 4.5, which is crushing it on coding benchmarks. Google's Gemini is now integrated into every single Google product you can think of. And OpenAI? Well, they were starting to look like they might be yesterday's news. But here's the thing about OpenAI. They don't go down without a fight. And today, they're swinging back hard with GPT 5.2. So what exactly did they build? Well, OpenAI is calling this their most capable model series yet for professional knowledge work. And I know that sounds like typical tech company marketing speak, but stick with me because the specs are actually pretty wild. They've created 3 different versions of GPT 5.2. There's Instant, which is optimized for speed in everyday tasks like writing and translation. There's Thinking, which is designed for complex structured work using deeper reasoning chains. And then there's Pro, which OpenAI is calling their smartest and most trustworthy option for when you absolutely need the highest accuracy. The context window is massive. We're talking 400,000 tokens. That means you can feed it hundreds of documents or entire code repositories all at once. And it can output up to 128,000 tokens in a single response. Now let's reveal OpenAI's most unexpected model yet. OpenAI dropped ChatGPT and created a revolution. They had no competition, no rivals. They owned artificial intelligence. But today, December 2025, they're dying. Sam Altman just sent an emergency message to every single employee. 2 words that shook Silicon Valley to its core. Code Red. Google is crushing them. Anthropic is outsmarting them. And for the first time since ChatGPT launched, OpenAI is losing the war they started. But what nobody knows, OpenAI has a secret weapon. A model so powerful that if Google and Anthropic found out about it right now, they'd be terrified. Its codename? Garlic. And this is the story of the most desperate comeback in tech history. Let's rewind. November 30th, 2022. OpenAI releases ChatGPT. Within 5 days, 1 million users. Within 2 months, 100 million. The fastest growing application in human history. Google panics. They declare their own code red. Microsoft invests $13 billion into OpenAI. The entire tech industry reorganizes around one question. How do we compete with ChatGPT? Fast forward to 2024. OpenAI releases GPT-4, then GPT-4 Turbo, then ChatGPT Plus with vision, with voice, with everything. They're unstoppable, right? By mid-2025, something changes. ChatGPT's growth, it flatlines. 800 million weekly users. But that number stops climbing. The hype, it's fading. The competition, it's catching up. December 2024, Google drops Gemini 2.0, then Gemini 2.5, then in 2025, Gemini 3. And it's not just good, it's better. Gemini 3 shoots to the top of every benchmark. Developers start switching, businesses start migrating. 450 million users in October, 550 million in November, 650 million in December. Gemini isn't just growing, it's exploding. And then there's Claude, Anthropic's model. Smaller company, but developers are calling it superior for coding. 300,000 business customers. A $200 million partnership with Snowflake. Plans for a $300 billion IPO. OpenAI's market dominance? Crumbling. Their technological lead? Vanishing. The company that started the revolution is watching everyone else run past them. And inside OpenAI headquarters, alarm bells are ringing. November 2025, Behind closed doors, OpenAI executives are in crisis mode. Projects are being killed, teams are being reorganized. The entire company is pivoting. That AI shopping assistant they announced, canceled. The advertising platform to generate revenue, healthcare AI initiatives, consumer hardware projects, everything stops. Because Sam Altman is about to address the entire company, and what he says next changes everything. We're in code red. Google is beating us in benchmarks. Anthropic is stealing our enterprise customers. We need to move faster than we've ever moved before. Now let's analyze DeepSeek v3.2 and its real performance. DeepSeek just dropped v3.2 and its Wild Speciale variant, and these open source models are claiming to match GPT-5 and rival Gemini 3 Pro, while crushing gold medal performance in 4 major international competitions. This isn't hype. This is a Chinese AI lab with limited chip access, somehow creating frontier-level reasoning models that the entire research community is talking about right now. Let me break down what makes this release genuinely different. DeepSeek released 2 models simultaneously. The standard v3.2 is designed as your daily AI assistant for reasoning tasks, positioned directly against GPT-5 in performance. Then there's v3.2 Speciale, which is the maxed-out reasoning beast that's matching Google's Gemini 3 Pro on the hardest benchmarks available. But here's what caught everyone's attention. DeepSeek v3.2 Speciale achieved gold medal level results in the 2025 International Mathematical Olympiad, the Chinese Mathematical Olympiad, the ICPC World Finals, and the International Olympiad in Informatics. These are competitions where only OpenAI and Google's internal unreleased models have hit this level before. We're talking about problems that stump most professional mathematicians and computer scientists. The technical innovation behind this is something called DeepSeek sparse attention. Traditional transformer models have a massive problem with long context windows because the computational cost grows quadratically as you add more tokens. Think of it like trying to remember every single word in a conversation that gets longer and longer. It becomes impossibly expensive really fast. DeepSeek's sparse attention changes this from quadratic complexity to nearly linear by intelligently deciding which past tokens actually matter for the next prediction. It runs a lightweight scoring pass to rank previous tokens by relevance, then only pays attention to the top candidates. What does this mean practically? Processing 128,000 tokens, roughly equivalent to a 300-page book, now costs about 70 cents per million tokens for decoding. That's compared to $2.40 with their previous v3.1 model. We're talking about cutting inference costs by more than half while maintaining the same quality output. That's absolutely massive for anyone building applications that need to process large documents, entire code bases, or lengthy research papers. The context window itself is 131,000 tokens, which puts it in the same league as the longest context models available today. And according to independent benchmarks, v3.2 is performing on par with or better than its predecessor, despite using this sparse attention mechanism. That's the engineering achievement here. They managed to reduce computational complexity substantially without sacrificing performance. Now here's where it gets really interesting for developers. DeepSeek v3.2 is the first model from this lab to integrate reasoning directly into tool use. Now let's see how Google tackled AI's memory problem.
All right, let's talk about what Google just pulled off with Titans, because this is genuinely wild. For the longest time, AI models have had this fundamental problem. They can't remember things properly, not in the way you or I remember. And Google might have just cracked it, but there's a catch, and we need to talk about that too. So here's the thing. Right now, when you're using ChatGPT or Claude or any of these models, they're not actually learning from your conversation in real time. They're just holding everything in temporary memory, like RAM in a computer. Once that context window fills up, they start forgetting stuff. It's like trying to have a deep conversation with someone who can only remember the last 10 minutes of what you said. Frustrating, right? Transformers, the architecture that powers basically every major AI model today. They're incredible at short bursts. They're precise, they're detailed, they understand nuance. But push them too far. Ask them to handle massive documents, or remember context from hours ago, and they crumble. The compute cost skyrockets, performance tanks, and suddenly your super intelligent AI can't remember what you told it 3 pages back. Google tried a different approach with Titans. Instead of just accepting these limitations, they built something that actually learns while it's running. And I mean genuinely learns, not just pretends to remember by searching through a long text file. Titans uses what they call a long-term memory module. It's separate from the main attention mechanism, and it updates dynamically as the model processes information. Here's where it gets interesting. Titans doesn't just save everything blindly, it's selective. It decides what's worth remembering based on surprise. If something unexpected shows up, something that doesn't fit the pattern, Titans flags it and stores it. And when it forgets, it doesn't just wipe old data randomly like most systems do. It forgets strategically, keeping what matters and letting go of redundant information. Google actually built 3 different versions of this memory system. Memory as context, memory as gate, and memory as layer. The one that performed best, memory as context, is the one that's making everyone's jaw drop. We're talking about context windows over 2 million tokens. That's not a typo, 2 million. For reference, GPT-4 Turbo handles around 128,000 tokens. This is on a completely different scale, and it's not just about capacity, it's about performance. Titans with only 760 million parameters, which is tiny by today's standards, outperformed models with tens of billions of parameters on long context tasks. On the needle in a haystack test, where models have to find specific information buried in massive documents, Titans hit over 95% accuracy at 16,000 tokens. Most models fall apart way before that. Then there's the Babylon benchmark. This is brutal. It tests whether a model can connect facts scattered across enormous texts, things that require actual reasoning across long distances. Titans didn't just beat other models, it destroyed them.
Now let's explore why Anthropic's Opus 4.5 matters. Anthropic just released Claude Opus 4.5, and the timing could not be worse for OpenAI. And Google, this model is not just an incremental upgrade. It is a direct shot at the competition, and the benchmarks prove it. Let me break down exactly what Opus 4.5 brings to the table, and why the 2 biggest names in AI should be looking over their shoulders right now. First, let's talk about what just happened in the past few weeks. Google dropped Gemini 3 Pro, and the industry lost its mind. Salesforce CEO Mark Benioff publicly announced he's switching from ChatGPT to Gemini. That's a massive endorsement, OpenAI. Sam Altman reportedly told his team that Google's release would create temporary economic headwinds for the company. The pressure was building. OpenAI responded with GPT 5.1 and their specialized Codex Max model designed for autonomous coding. And then Anthropic walked in and flipped the table. Claude Opus 4.5 just became the first AI model in history to break 80% on Bench. Verified for those unfamiliar. This is one of the most respected benchmarks in the industry for measuring real-world software engineering capability. We're not talking about toy problems here. This tests how well an AI can actually write, debug, and improve production-level code. Opus 4.5 hit 80.9%. OpenAI's GPT 5.1 code X Max scored 77.9%. Google's Gemini 3 Pro came in at 76.2%. Anthropic's own Sonnet 4.5 from just a few weeks ago scored 77.2%. That 3-point gap between Opus 4.5 and the competition might not sound like much, but at the frontier of AI development, a 3-point lead is enormous. It represents countless engineering hours and research breakthroughs that the competition hasn't figured out yet. But here's where it gets really interesting. Anthropic didn't just release a slightly better model. The pricing on Opus 4.5 dropped by 67% compared to the previous version we're now looking at. $5 per $1 million input tokens and $25 per $1 million output tokens. The old Opus 4.1 was $15 and $75 respectively. That is a massive reduction. Anthropic essentially made their most powerful model accessible to developers and businesses who previously couldn't afford to experiment with frontier capabilities. This is a strategic move that puts pressure on both OpenAI and Google, when your best model is not only outperforming the competition, but also undercutting them on price. That's a combination that wins market share fast. Now let's talk about what this model can actually do, because the capabilities are genuinely impressive. Anthropic gave Opus 4.5. Now let's focus on the one thing that defines Gemini 3 Pro. Google just dropped Gemini 3 Pro, and honestly, this might be the biggest AI power move we've seen in months. Just when we thought OpenAI had the spotlight with GPT 5.1, Google swoops in and completely steals the show with a model that's topping every major benchmark out there. And they're not playing around with this one. So here's what happened. Google DeepMind released Gemini 3 Pro today, calling it their most intelligent model ever. Bold claim, right? But they've got the receipts to back it up. This thing just hit 1501 on the LM Arena leaderboard, dethroning Grok 4.1, thinking that was sitting pretty at the top. For context, that's a massive jump from Gemini 2.5 Pro, which scored 1451. We're talking about a model that came out just 7 months ago being absolutely obliterated by its successor. But what makes Gemini 3 Pro actually special? Let's break this down because there's a lot to unpack here. First up, the reasoning capabilities are genuinely impressive. Google is claiming PhD-level reasoning performance, and the benchmarks seem to support this. On humanity's last exam, which is designed to test the absolute limits of AI reasoning, Gemini 3 Pro scored 37.5% without using any tools. That might not sound massive until you realize this is one of the hardest AI benchmarks ever created. They also crushed GPQA Diamond with a 91.9% score, which tests graduate-level scientific reasoning. Mathematics has always been a weak point for language models, but Gemini 3 Pro is changing that narrative. It set a new record on MathArena Apex with 23.4% accuracy. Now, before you think that sounds low, understand that these are extremely complex mathematical problems that require multiple steps of logical reasoning. The previous best scores were nowhere close to this. The multimodal capabilities are where things get really interesting. Gemini 3 Pro isn't just processing text anymore. It's seamlessly working with images, video, audio, and code all at once. On MMMU Pro, which tests multimodal understanding, it scored 81%. For video understanding on Video MMMU, it hit 87.6%. This means the model can actually watch a video and understand what's happening with near-human accuracy. Now here's where Google is making a bold play. They're introducing something called vibe coding with Gemini 3 Pro. Think of it as AI that doesn't just write code, but actually understands the vibe or aesthetic you're going for. Want to build a retro spaceship game? Just describe it and Gemini 3 creates it with the right visual style and interactivity. It's not just generating generic code anymore. It's creating experiences. Speaking of coding, Google also launched Anti-Gravity today. This is their new agentic development platform that lets AI work across your editor, terminal, and browser simultaneously. Now let's see how a Chinese AI beat GPT-5. China just dropped a bomb on the AI world. Moonshot AI's Kimi K2. Thinking is now officially beating GPT-5 and Claude Sonnet 4.5 on multiple benchmarks. And here's the kicker. It's completely open source. We're talking about a Chinese model that cost just $4.6 million to train, outperforming models from OpenAI and Anthropic that likely cost billions. This isn't just another model release. This is a genuine shift in the AI landscape. Let me put this into perspective. For the longest time, open source models have been playing catch-up, trailing behind closed proprietary systems by at least 3 to 6 months. Companies like OpenAI, Anthropic, and Google have been leading with a comfortable margin. But Kimi K2 thinking just shattered that dynamic. It scored 44.9% on humanity's last exam, a benchmark so notoriously difficult it's designed to test PhD-level knowledge across multiple domains. GPT-5 scored 41.7%. Claude Sonnet 4.5 scored just 32%. And we're not talking about a marginal lead here. This is a significant performance gap. But the benchmark dominance doesn't stop there. On BrowseComp, which tests a model's ability to search, browse, and reason over real-world web information, Kimi K2 thinking crushed it with 60.2%, GPT-5 managed 54.9%, and Claude barely hit 24.1%. In coding benchmarks like SWE Bench Verified, it scored 71.3%. These aren't small wins. These are the kinds of results that make people in the AI community stop and say, wait, what just happened? Now you might be wondering what makes Kimi K2 thinking so special. The secret sauce is something called interleaved reasoning. Traditional reasoning models think everything up front, produce one long chain of thought, and then deliver a final answer. It's like planning an entire road trip before you leave the house. But if your initial plan has a flaw, the whole thing falls apart. Interleaved reasoning works differently. It takes incremental steps, thinks a bit, acts, evaluates the result, thinks again, and keeps going. It's more like how humans actually work. You try something, see what happens, adjust your approach, and move forward. This makes Kimi K2 thinking incredibly powerful for what we call agentic tasks. These are complex workflows where the AI needs to use multiple tools, make decisions on the fly, and work through problems that require dozens or even hundreds of steps. Kimi K2. Thinking can execute 200 to 300 sequential tool calls without any human intervention. It's doing cycles of think, search, browse, code, think again, all autonomously. This is what true AI agents look like, and it's operating at a level we haven't seen before in an open model. Now let's talk about Microsoft's AI scientist moment. Microsoft just deployed an AI that runs for 12 hours straight and makes actual scientific discoveries while you sleep. KOSMOS isn't just another chatbot. It's reading 1,500 research papers, writing 40,000 lines of code, and uncovering real medical breakthroughs completely on its own. And that's just the beginning of what dropped this week. Google launched an autonomous data scientist that debugs its own code. China released a reasoning model that chains 300 consecutive thoughts without human intervention. And Microsoft announced plans for something they're calling humanist superintelligence. The AI landscape just shifted dramatically. Let's talk about KOSMOS first, because this one genuinely changes everything. You feed it a data set. Brain scans, genetic sequences, material science data, doesn't matter. Hit start and walk away. For the next 12 hours, it becomes a tireless research machine. No coffee breaks, no distractions, just pure scientific investigation. Here's what it discovered in early trials. It found that cooling protects brain cells by forcing them into energy-saving mode, where they recycle molecules instead of creating new ones. It identified the exact humidity threshold that destroys perovskite solar cells during manufacturing. It mapped a universal mathematical pattern for how neurons connect across every species from flies to humans. These aren't theoretical predictions. Human researchers confirm these findings. The system runs hundreds of specialized agents working in parallel. Some read papers, others analyze data, others write and test code. They all share a single memory system that tracks everything. What's been tried, what worked, what needs testing next. Independent reviewers found nearly 80% of its scientific statements were accurate. One 12-hour KOSMOS session produces roughly 6 months of human research output. But Microsoft's ambitions go way beyond autonomous research. Mustafa Suleyman just announced their vision for humanist superintelligence. Not an AI that replaces humans, but one designed explicitly to serve them. Think of it as bounded intelligence with human values hard-coded into its core. This directly challenges OpenAI's approach. Microsoft can now develop AGI independently, thanks to their new licensing deal with OpenAI's intellectual property. The competition between these former partners is about to get intense. Meanwhile, China's Moonshot AI dropped Kimi K2, an open-source reasoning model that's absolutely wild. Give it a PhD-level hyperbolic geometry problem and watch it execute 23 nested reasoning steps. Search academic papers, write Python code, verify intermediate results, and derive the correct formula. All without human guidance. K2 scored 44.9% on humanities' last exam, a benchmark spanning over 100 expert-level disciplines. On continuous browsing and research tasks, it hit 60.2%, literally doubling human baseline performance. Now let's separate hype from reality at DeepMind. Google DeepMind just launched Pomelli, and this could completely change how small businesses handle their marketing. We're talking about an AI tool that learns your brand's entire identity from your website, and then pumps out professional marketing content in seconds. No design team required, no massive budget needed, just you, your website, and an AI that gets your vibe. Here's what makes this interesting. Pomelli isn't just another generic AI content generator that spits out bland cookie-cutter posts. This thing actually studies your business. It analyzes your website and creates what Google calls your business DNA. Think of it like taking a snapshot of your brand's soul. Your colors, your fonts, your tone of voice, even the types of images you use. It builds a complete profile so everything it creates actually feels like it came from you. The way it works is surprisingly straightforward. You paste in your website URL and Pomelli goes to work. It's scanning your site, picking up on your logo, understanding your visual aesthetic, reading your copy to figure out how you communicate. Within moments, it's got your entire brand identity mapped out. This solves the biggest problem with most AI marketing tools right now. They feel generic. They feel like a robot made them. Pomelli grounds everything in your actual brand, making the output feel authentic. Once it understands your business, the creative part kicks in. Pomelli can automatically suggest campaign ideas based on what you do, or you can guide it with your own prompts. Let's say you run a fitness studio. You could type something like, "Help me promote my new yoga classes," and Pomelli will generate social media posts, ad banners, and taglines that match your brand's energy. It's basically like having a marketing team brainstorming with you, except it happens in seconds instead of scheduling 3 meetings over 2 weeks. The really clever bit is how it turns those ideas into actual usable content. We're not talking about rough drafts here. Pomelli creates finished posts and ads that you can edit, tweak, and download immediately. Want to change the headline? Done. Swap out an image? Easy. Adjust the call to action button? Takes 2 clicks. Everything stays on brand because it's all built from that business DNA it created at the start. Now let's meet Microsoft's emotional AI, Mico. Microsoft just launched Mico, an emotional AI orb that lives inside Copilot, and it's basically Clippy's revenge arc. This glowing sphere reacts to your tone, remembers your conversations, and genuinely changes expression while you're talking. It blinks. It smiles. It even tilts when you sound confused. And somehow, it's not creepy. It's actually useful. The rollout started quietly a few months back, but now it's going live by default across the United States. Mico isn't just a chatbot with a face. It's tied directly into Copilot's new memory system, which means it knows what projects you're working on, what questions you asked last week, and what you're trying to accomplish today. That persistence changes everything. You're not starting fresh every conversation. You're building into actual relationship with software. Microsoft's calling it the evolution of what they tried with Cortana back in 2015. But let's be honest, Cortana was clunky. Voice assistants a decade ago felt like shouting commands at a confused robot. Mico feels different because it listens, processes tone, and adjusts. If you're frustrated, it picks up on that. If you're excited, it mirrors it. That emotional feedback loop is new territory. Jacob Andre, Microsoft's VP of Product and Growth, said Clippy walked so we could run. And he's not wrong. Clippy was annoying because it guessed what you wanted and interrupted constantly. Mico waits. It observes. It only steps in when you engage. That shift from reactive to responsive is subtle but massive. There's also a feature called Learn Live Mode that turns Mico into a Socratic tutor. Instead of just answering your questions, it guides you through problems with whiteboards and step-by-step visuals. Imagine prepping for an exam and having an AI that doesn't just tell you the answer, but walks you through why the answer works. That's genuinely powerful for students, language learners, or anyone picking up a new skill. Mustafa Suleyman, Microsoft's AI chief, has been hinting at this direction for months. He wants Copilot to have a real identity. He said it will have a room it lives in, and it will age over time. That sounds wild, but it's part of a bigger push toward human-centered AI. Microsoft's betting that people don't just want tools, they want companions. The marketing reflects that shift. New Windows 11 ads are literally calling it the computer you can talk to. And unlike Cortana, which got shut down on Windows 11 after barely anyone used it, Mico's already showing traction. Microsoft even added Easter eggs. If you poke the orb repeatedly, something unexpected happens. Those little touches make it feel alive in a way that previous assistants never did. But while Microsoft's reviving old mascots with new tech, now let's explore a real-world quantum breakthrough. Google just announced they've achieved something called verifiable quantum advantage with their Willow chip. And this isn't just another incremental step in quantum computing. This is the moment where quantum computers prove they can solve real problems. Faster than any classical supercomputer on Earth, and we can actually verify the results. Let me explain why this is absolutely massive. The breakthrough revolves around something called quantum echoes. Now, before your eyes glaze over, think about how a bat navigates through a dark cave. It sends out sound waves that bounce back, creating echoes that reveal the cave's structure. Google's quantum team essentially did the same thing, but inside a quantum system. They engineered quantum echoes that bounce through their chip, revealing hidden information about how quantum systems actually work. Here's where it gets wild. Their Willow chip ran this algorithm 13,000 times faster than the world's best classical supercomputers. 13,000 times. That's not a typo. But speed alone isn't what makes this historic. What makes this truly groundbreaking is that it's verifiable. The results can be repeated and checked against other quantum systems, even nature itself. This is the first time any quantum computer has achieved verifiable quantum advantage, and that distinction matters more than you might think. For years, quantum computing has been stuck in this weird limbo. We've had demonstrations of quantum supremacy, but critics could always argue about whether the problems being solved were actually useful or just party tricks designed to make quantum computers look good. Verifiable quantum advantage closes that door. We're not just doing quantum computing anymore. We're doing quantum science that maps to real-world physics. So what exactly is happening inside Willow when it runs these quantum echoes? The chip contains 105 qubits arranged in an array. The team runs a specific sequence of quantum operations called gates across this array. Then they perturb a single qubit, creating what's essentially a butterfly effect inside the quantum system. After that, they run the exact same sequence of gates in reverse. The forward signals and reverse signals interfere with each other, creating these echo patterns that encode information about the quantum system's behavior. The technical term for what they're measuring is an out-of-time order correlator. Don't worry about memorizing that. What matters is that this value tells us how different parts of a quantum system interact across time and space. Scientists have wanted to measure this in large quantum systems for decades. But the signals were always too faint, buried under layers of noise and errors. Willow changed that equation. The chip itself is built from superconducting integrated circuits that deliver incredibly accurate quantum gates, combined with sophisticated error. Now let's look at what makes Google VEO 3.1 powerful. Google introduces VEO 3.1, the most advanced AI video generation model yet. VEO 3.1 brings native audio generation, enhanced prompt adherence, and unprecedented realism to both text and image-to-video creation. You can now extend clips beyond 60 seconds, blend multiple reference images, and create seamless transitions between frames with synchronized sound. Powered by Google's Gemini API and Flow, VEO 3.1 transforms your ideas into cinematic reality with a single prompt. In this video, I'll show you exactly how VEO 3.1 works, its groundbreaking features, and why creators are calling it a game changer. Released on October 15, 2025, VEO 3.1 is Google's response to 5 months of creator feedback since VEO 3 launched at Google I/O. With over 275 million videos already generated in Flow, Google has refined their model to address real creator needs. This isn't just an update, it's a complete reimagining of AI video generation. The technical specifications are impressive. VEO 3.1 generates 1080p Full HD videos at 24, 30, or 60 frames per second. Both 16.9 landscape and 9:16 portrait formats are supported. While base generation remains at 8 seconds, the Extend feature allows chaining clips to create videos lasting over 1 minute with maintained continuity. Native audio generation sets VEO 3.1 apart from competitors. The model generates synchronized dialogue with accurate lip sync, ambient sounds, sound effects, and background music simultaneously with video creation. No more silent AI videos requiring separate audio production. Flow's new ingredients to video feature accepts up to 3 reference images to control characters, objects, and visual style. VEO 3.1 intelligently blends these elements, handling lighting, shadows, and interactions naturally. This feature is available in Flow, Vertex AI, Gemini API, and the Gemini app. Frames to Video provides unprecedented control over transitions. Supply a starting and ending frame, and VEO 3.1 generates the motion between them with complete audio. Perfect for reveal shots, transformations, and creative scene bridges. This feature works in Flow, Vertex AI, and Gemini API. The Extend feature revolutionizes long-form AI video creation. Each extension continues from the final second of your previous clip, maintaining motion, lighting, and audio continuity. Available in Flow and Gemini API, with Vertex AI support coming soon. Google offers two variants. VEO 3.1, standard delivers maximum quality for professional projects. VEO 3.1, fast optimizes for speed and cost efficiency while maintaining high quality. API pricing runs $0.40 per second for standard and $0.15 per second for fast. Now let's uncover Samsung's smallest AI surprise. Samsung just built a 7 million parameter AI model that absolutely destroyed Gemini and DeepSeek at reasoning tests, and the entire AI community is losing their minds trying to figure out how this is even possible. This tiny model called TRM just scored higher than systems with literally thousands of times more parameters. And the way it works is genuinely brilliant. Here's the insane part. On the ARC AGI reasoning benchmark, this microscopic model hit 45% accuracy while DeepSeek R1, with its billions of parameters, only managed 15.8%. Gemini 2.5 Pro got 37%, even OpenAI's O3 Mini only reached 34.5%. Samsung's tiny model just embarrassed the entire industry with what amounts to a rounding error worth of compute. The secret is that TRM doesn't think like other models at all. Regular language models generate text one token at a time, basically guessing the next word and hoping the sentence makes sense by the end. It's like trying to paint a masterpiece while blindfolded, adding one brushstroke at a time. TRM takes a completely different approach. It writes an entire answer, looks at it, decides it's garbage, and rewrites it. Then it does that again, and again, and again, 16 times before you ever see the output. Think about that for a second. Every other model is committed to its mistakes. Once GPT-4 starts writing a wrong answer, it's stuck with it. But TRM has this internal scratch pad where it can think privately, realize it's being an idiot, and completely start over. It's basically given itself an undo button that it can spam until it gets the right answer. The architecture is stupidly simple too. 2 layers, that's it. Not 200 layers like some massive transformer. Just 2. But here's the genius move. Instead of stacking layers vertically to create depth, it loops horizontally. It's the difference between building a skyscraper and just walking around the same 2 floors 16 times until you've covered enough ground. Turns out, the walking strategy works better for reasoning. Samsung's team also pulled off something clever with how the model handles different types of problems. For big complex puzzles like navigating mazes, they use self-attention, the standard transformer approach. But for smaller, more structured problems like Sudoku, they switched to something called an MLP mixer, which basically just shuffles tokens around without all the computational overhead. It's like having 2 different engines in the same car and switching between them based on the road conditions. The results are honestly comedy gold. They trained this thing on just 1,000 Sudoku puzzles. 1,000. Then they tested it on 423,000 puzzles it had never seen. It solved 87.4% of them correctly. Now let's see how XAI made AI faster and cheaper. XAI just rolled out Grok 4 Fast, a new version of its model that aims for top-tier thinking at a much lower cost. The core idea is brilliantly simple. Achieve performance incredibly close to the flagship Grok 4, but by using significantly fewer processing steps. The result? A staggering 98% reduction in cost to hit the same benchmark results as Grok 4. Making advanced AI accessible to a much broader audience. For anyone grappling with hefty AI bills, this is a massive win. But the speed and savings don't come at the expense of brainpower. Grok 4 Fast performs remarkably well across standard tests, often landing right alongside its more expensive predecessor. In fact, independent analyses have even rated its value-to-performance ratio higher than models like GPT 4.1, Gemini 2.5, and Claude 4, with extended reasoning. It consistently posts strong results in reasoning and math, even pulling ahead of Grok 4 in certain areas. While its coding abilities remain robust, where it truly shines is in its masterful use of tools. This model has learned to autonomously decide when to execute code, when to browse the web, and how to navigate between links. Like a seasoned assistant. Imagine an AI that can read posts, images, and even videos from X, then seamlessly weave all that information into a coherent answer. We saw this in action during a live demonstration where it accurately calculated the exact experience points needed to reach level 100 in Path of Exile 2, cross-referencing multiple sources to confirm the level cap. This isn't just a lab demo anymore. It's a default, intuitive skill that brings us closer to true AI agent behavior. Grok 4. Fast is engineered for versatility. It effortlessly shifts from firing off quick answers to simple questions, to engaging in deep, complex reasoning, without needing to switch models. Think of it as one brain with two modes, minimizing lag and optimizing token usage. Its memory is equally impressive, boasting a massive 2 million token context window. This allows for incredibly long conversations and the processing of vast documents, making it invaluable for extensive research, legal reviews, game design, and complex enterprise workflows spanning countless files. Getting access is straightforward. Grok 4. Fast is live on Grok.com, available in the iOS and Android apps, and developers can tap into it via the XAI API. In both reasoning and non-reasoning versions, both featuring that immense memory window. Pricing is competitive, billed per million tokens with special rates for lower token usage and live search bills per thousand sources. Plus, for a limited time, you can even try it for free on OpenRouter. Now let's see how AI is moving onto your phone. Liquid AI's latest release, LFM2VL, is more than just another model. It's a game changer. Imagine a vision language AI so powerful it can run directly on your phone, laptop, or even a wearable device. Now imagine it doing that at up to twice the speed of some of the most powerful models on the market. That's what LFM2VL promises, and it could be the moment real multimodal AI finally becomes a truly personal technology. Before we dive into what makes this so revolutionary, let's talk about the team behind it. Liquid AI emerged from MIT's Computer Science and Artificial Intelligence Laboratory, a group known for their foundational research. Instead of simply building bigger and bigger models, which has been the industry standard for years, they've been rethinking how AI is designed from the ground up. Their approach, based on principles from mathematics and signal processing, results in what they call liquid foundation models, or LFMs. These models are lighter, faster, and more adaptable than the competition. With the new LFM2VL, we're seeing this philosophy in action. Their core motto is, "Efficiency is our product," and it's clear they mean it. So what exactly is LFM2VL? It's a family of vision language models engineered for low latency and device awareness. In simple terms, this means they respond incredibly fast and are designed to run on the everyday devices we all use. There are two main versions. The smaller one, LFM2VL450M, is built for devices with severe resource constraints, where every bit of memory is precious. The larger version, LFM2VL1.6B, is more capable but still compact enough to run on a single GPU or a modern mobile device. Typically, models with this much power would need massive server farms to function, so this is a significant leap forward. The real headline here is speed. Liquid AI claims these models are up to 2 times faster at inference on GPUs compared to other vision language models. This isn't just a marketing claim. It means cutting processing time in half. This is the difference between a sluggish, frustrating assistant and one that feels truly responsive and seamless. Now let's get into the technical details and explore how these models are built, because this is where Liquid AI's unique approach truly shines. Now let's talk about China's trillion-parameter leap. China didn't just step up its game. It unleashed not 1, but 2 trillion-parameter AI models, sending ripples through the entire industry. What was once a subtle hum in the background has now become a roaring challenge to the established titans of artificial intelligence. Are we witnessing a dramatic shift in the AI arms race? Let's dive into the beast that just landed. First up is Alibaba's Qwen team, which has been making waves all year, now unveiling their Qwen 3 Max preview. This isn't just another incremental update, it's a colossal leap, boasting over 1 trillion parameters. To put that into perspective, for a long time, the industry speculated that OpenAI's most advanced models were operating around this scale. Yet, recent trends have seen many labs focusing on smaller, more efficient models. Qwen's decision to go all in on this massive scale is a bold and striking move. But it's not just about raw size. The benchmarks speak volumes. The Qwen 3 Max preview has consistently outperformed formidable models like Claude Opus 4, Kimi K2, and even DeepSeek V3.1 in various challenging tests. This is a significant declaration of capability, as these are some of the toughest models to beat right now. So, how does this translate into practical use? The model is already live through QuenChat, Alibaba's direct competitor to platforms like ChatGPT. It's also accessible via Alibaba Cloud's API through OpenRouter, and is even integrated as the default option in any coder, a popular open-source coding tool. This means developers worldwide are going to encounter Qwen 3 Max almost immediately, whether they expect it or not. However, there's a crucial detail. Unlike some of Qwen's previous releases, this one isn't open source, at least not yet. Access means going through Alibaba Cloud or one of it. Now let's see what GPT Image 1.5 improved.
OpenAI just dropped GPT Image 1.5, and this might be the biggest image generation upgrade we've seen all year. We're talking 4 times faster generation speeds, surgical precision editing, and a complete redesign of how you create images in ChatGPT. This isn't just another incremental update. This is OpenAI saying they're done playing catch-up with Midjourney and going straight for the professional creative market. So what makes GPT Image 1.5 such a massive deal? Let's start with speed. 4 times faster than the previous version. That means instead of waiting around watching a loading bar, you're getting your images almost instantly. For anyone who's tried to iterate on designs or create multiple variations, you know how much time this saves. We're not talking seconds here and there. We're talking about the difference between getting your work done today versus tomorrow. But speed is just the beginning. The real magic is in the editing capabilities. Here's what used to happen with AI image generators. You'd ask it to change someone's hair color, and suddenly the entire face looks different. You'd try to add a coffee cup to someone's hand, and boom, the lighting's wrong, the composition shifts, and you're basically starting over. GPT Image 1.5 changes that completely. It now understands exactly what you want to change and leaves everything else untouched. Same lighting, same composition, same facial features. It's like having a professional photo editor who actually listens to your instructions. This is huge for practical use cases. Imagine you're working on a marketing campaign and need to show the same product in different settings. Or you're creating a storyboard where character consistency matters. Before, you'd be playing Russian roulette with each generation, hoping the AI doesn't completely reimagine your character. Now you can make targeted edits while keeping the essence of your original image intact. Want to try different hairstyles on the same person? Done. Different outfits? Easy. Change the background without touching the subject? Absolutely. OpenAI has also completely redesigned how you interact with images in ChatGPT. Instead of burying image generation in the chat interface, there's now a dedicated ChatGPT Images workspace. Think of it as your creative studio right in your browser. You get preset styles, trending prompts for inspiration, and an interface actually built for visual work. No more scrolling through chat history trying to find that one image you generated 3 hours ago. Everything's organized, everything's accessible, and everything's designed to help you create better images faster. The text rendering is another area where GPT Image 1.5 shines. Anyone who's tried to generate images with text knows the struggle. You get jumbled letters, weird spacing, or text that looks like it went through a blender. The new model handles dense text, small text, even complex layouts. You want to create a realistic newspaper? It'll actually look like a newspaper with readable text.
Now let's see how robots are reshaping factories.
China just quietly dropped something that completely flips the script. And honestly, it makes so much more sense than what everyone else is doing. You're in a factory, and there's a robot that doesn't just have 2 arms like a human. It has 6 fully functional arms working simultaneously. And before you think this is some concept video or far-off prototype, this thing is rolling into an actual factory in China by the end of this month. We're talking weeks, not years. The robot's called Miro-U, made by Midea Group, and here's what's brilliant about it. Instead of trying to perfectly copy human movement, which let's be honest is insanely complex and kind of pointless in a factory, they asked a better question. What if we just focused on getting more work done? And that's exactly what they built. Miro U sits on a wheeled base, which immediately tells you they're thinking practically. No wobbly balance issues, no falling over, just fast, stable movement. It's got a lifting system so it can adjust height. And it spins a full 360 degrees without moving the base. But here's where it gets really interesting. Those 6 arms aren't just for show. The lower arms handle heavy lifting and positioning. The upper arms do precision work, fastening, assembly, the detailed stuff. And it can do 3 different tasks at the same time in the same space. Think about what that means for a production line. Usually, when factories change over between different products, they lose massive amounts of time. You need multiple workers, or you're swapping out equipment, reconfiguring stations. MIDIA reckons Miro U can boost changeover efficiency by 30%. That's huge money we're talking about. And get this, Meta's CTO literally called it a super humanoid. Now normally that's just marketing fluff, but in this case, it kind of fits. This robot genuinely does things humans can't. It works at multiple height levels, spins without repositioning, swaps tools instantly, and has stamina we simply don't have. What's really telling is that MIDIA isn't just throwing robots at walls to see what sticks. They bought the German robotics company KUKA back in 2017, so they've got serious industrial automation knowledge.
Now let's see how Apple made AI insanely fast.
Apple has just quietly unveiled a groundbreaking new vision language model called FastVLM. And the numbers associated with it are absolutely staggering. We're talking about a system that's reportedly 85 times faster, 3 times smaller, and yet powerful enough to run smoothly on a standard MacBook Pro. This isn't just an incremental update. It could be the long-awaited breakthrough that finally allows AI to truly see, understand, and interact with our world in real time, right on our devices. But why is this so critical? Why does a faster, smaller VLM matter so profoundly? To understand, let's break down what VLMs are and the fundamental challenge they face. Vision language models are the cutting edge of AI, designed to bridge the gap between text and images. Instead of simply asking an AI to write an essay, you can now show it a complex chart, a technical diagram, a scanned document, or even a simple screenshot, and expect it to comprehend the visual information and respond intelligently. Imagine asking an AI about the trends in a graph, or explaining a part of a technical drawing. That's the power of VLMs. However, there's always been a catch, a significant bottleneck that has held these systems back: resolution. Detail is everything. If your input image is low resolution, the AI simply misses crucial information. It's like asking someone to describe a painting while only showing them a blurry thumbnail. But if you try to solve this by cranking up the resolution to capture every nuance, you run headfirst into a different, equally frustrating problem. Suddenly, the vision encoder, the part of the model that processes the image, has to grapple with an overwhelming amount of data. This translates into a huge increase in visual tokens, the discrete pieces of information the AI uses to represent the image. More tokens mean more processing, which inevitably slows everything down, both on the visual analysis side and when the language model tries to generate a response. That frustrating delay you experience when waiting for the AI's first words to appear on screen? That's what's known as time to first token, or TTFT, and Apple has been utterly obsessed with minimizing it in this new project. Over the years, researchers have tried countless ingenious tricks to make vision language models faster and smarter. Early systems, like Frozen and Florence, pioneered a technique called cross-attention. This essentially meant weaving the image and text information together deeply within the language model's layers, allowing them to interact and influence each other very closely. Later, the field gravitated towards what are known as autoregressive approaches. Models such as Lava, PlugOwl, Mini GPT-4, and Cambrian-1 took a different route. Instead of,
now let's look at how AI is entering everyday life. Apple are not just upgrading Siri, they're liberating it, transforming our familiar digital assistant into an AI robot capable of movement, observation, and natural conversation. This isn't just an update, it's a leap, potentially the boldest step they've ever taken in the AI landscape. But the revolution doesn't stop with Apple. Around the globe, robotics and AI are bursting into reality with breathtaking speed, touching every aspect of our lives. Consider China, where scientists have engineered a robot that can pollinate crops autonomously, hinting at a future where global food shortages could become a relic of the past. Or journey to Johns Hopkins University, where an AI robot has demonstrated the ability to perform complex surgery with a precision that rivals human masters. In California, AI-powered robots are dramatically accelerating the rebuilding of homes in wildfire-devastated areas, showcasing their potential in disaster recovery. Beijing recently hosted the world's first-ever humanoid robot games, a spectacle of machines competing in races and combat, sometimes with comical tumbles, but always pushing the boundaries of what's possible. And as if that weren't enough, HTC has just joined the fray with sleek new AI smart glasses, poised to challenge tech giants like Meta and Apple in the burgeoning wearable tech market. It's a whirlwind of innovation, all happening right now. So, let's unpack these incredible advancements, starting with Apple's grand vision for Siri. For years, Siri has been, for many of us, a somewhat static, at times frustrating, voice trapped within our iPhones. But Apple's internal plans envision a complete metamorphosis. They're rebuilding Siri from the ground up, not just as a voice, but as a dynamic presence, integrated into a whole new ecosystem of smart devices and, most astonishingly, robots. And this was AI in 2025, the breakthroughs, the risks, and the future taking shape right now. If you want to stay ahead of what's coming next, subscribe to AI Perspectives, where we break down the future of AI.